Hey guys, welcome back. We are up to exercise 3E today, looking at trigonometric ratios. So, trigonometric ratios. What does trigonometry mean? Trigon, when we know about polygons, many sides, a trigon is a three straight-sided shape, or a triangle. And metric, that's to do with measuring, isn't it? The metrics of something. So, measuring triangles, and in particular, angles and side lengths. That's what trigonometry is going to do for us. What we need to get out of today is to know how to label the sides of a right-angled triangle. We've been doing this before, where we've labelled the hypotenuse. Now, when we've got a particular angle, we're also going to learn how to label one side, the two legs they were originally called. We're going to label them as the opposite and adjacent. Opposite across from the angle, adjacent next to the angle. Let's have a look and see how it goes. So we've got the three sides. So here's an example here. I've got a right-angled triangle, so across the triangle from the right angle, the longer side is the hypotenuse. We know that from Pythagoras' theorem. Then if I've got an angle in this lower right corner, then directly opposite across the triangle, in between the two sides that form the angle, opposite that is the quite appropriately named opposite side. The remaining side is adjacent or next to the side, and obviously there are two sides next to the angle, but one of them's the hypotenuse, so it's got to be the other one. Here we are again in the second one there. Opposite is directly across, adjacent next to. I don't know that my little pointer was working there. So adjacent next to, opposite straight across. Hypotenuse, of course, the longest one, opposite the right angled triangle. And there are three different trigonometric ratios that we need to know. Now, my pen doesn't want to work, but let's see if I can get it to go. So the first one is the sine of an angle, or sine theta. So you've seen that on your calculator and you've all called it sin because that's what it looks like, and that's the only way we've read that letter, those three letters in that order before, but we're actually going to read it as sine. That's just the shorthand way of writing sine with an E on it. And that's the ratio of the opposite side divided by the hypotenuse. The cosine of an angle, or cos, as you would have seen it on your calculator, is the adjacent side divided by the hypotenuse, and the tangent of an angle, the tan ratio, is the opposite side divided by the adjacent. Now we need to remember those, and some people, obviously you need a little mnemonic or some way of remembering them, and the term that we tend to use to do that is SOHCAHTOA. So SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent. If we remember that, you're going to find this section very easy. Let's just make sure we can do that. Here's my worked example. So let's have a look. Using the given sides, write a trigonometric ratio in fraction form for each of the following triangles. Your first step is always to label your triangle. So there's my right angle, so this must be the hypotenuse. Here's the angle I've been given, so across the triangle is the opposite side, and next to the angle is the adjacent side. So look at that and I go, well, here I need the hypotenuse and the adjacent side. And I ask myself, SOHCAHTOA, adjacent and hypotenuse. That's opposite and hypotenuse. Here it is, adjacent and hypotenuse. Cosine has the adjacent and hypotenuse. So it's going to be the cosine ratio that I need for this one. So I'm going to write the cosine of theta is equal to the adjacent side, 5, divided by the hypotenuse, which is 7. And that's all there is to these ones. What about the next one? I label my triangle. Let's use a different color so we know they match up. Here is my hypotenuse because it's opposite the right angle. I draw another arrow opposite the angle. That's going to be the opposite side, which means the one next to it that I haven't labeled yet is the adjacent side. So this time I'm interested in an opposite side and a hypotenuse. So I go opposite and hypotenuse. That's from the SAW, sine equals opposite over hypotenuse. So I now know that I need to write the sine ratio. The sine of theta is equal to the opposite side, 4, divided by the hypotenuse, which is 9. Let's have a go at lucky last here. Labeling my triangle, there's my right angle, so across the triangle is the hypotenuse. Now I could label the adjacent side next if I wanted to, and the opposite side last. That's fine, but always start with that hypotenuse. That's most important. So in this one, I'm interested in an opposite side and an adjacent side. That's the tangent ratio. Oh, okay. So the tan of theta is going to be the opposite side 3 divided by the adjacent side 5. And that's all we want to get out of these today. Being able to identify using SOHCAHTOA and labeling the triangle which ratio I need to use, and then being able to write the ratio. There are 3 over there for you to have a try at. If you want to pause the video now and give them a try, I'm going to come back with the answers as soon as you press play again. Alright, so hopefully you've done that. Let's have a look and see how you went. This one here, I'm quickly labeling my triangle, hypotenuse, opposite, adjacent. So that's going to be opposite and adjacent, that's my tan ratio. So the tan of theta equals the opposite side 6 divided by the adjacent side 5. Next one here, that's going to be a hypotenuse. This is my adjacent side because it's next to. So adjacent and hypotenuse, that's cosine. Cosine theta equals adjacent size of 3, hypotenuse of 8. Finally, lucky last here, that's my hypotenuse. The other angle I know is the opposite one. Opposite and hypotenuse is sine, so the sine of theta equals the opposite side 2 divided by the hypotenuse 3. Good luck, get stuck into those questions. I think you're going to find these pretty easy today. Hopefully that's the case. If you want to stick around, I'm going to show you 3 bonus ratios that aren't in your book, that do exist, and you're going to come across them later on. Otherwise, if you just want to get stuck into your work, that's fine. I'll say bye for now, and for everyone else, you can stick around. I'm going to teach you the other 3 ratios. Alright, so what are these other 3 secret ratios that the clever people have stuck around to hear about? Well, if you take 3 sides and we're turning them into ratios, each of these, I could have a reciprocal ratio where I wrote them the other way around. So let's make a little section over here. Bonus 3 ratios. Trigonometric ratios. If only I could spell and speak at the same time. These are sometimes called the reciprocal ratios. Reciprocal, you'll remember, is to turn a fraction upside down. So here I've got my angle. This would be the hypotenuse, the opposite, and the adjacent side. So we have 3 other ratios. Let's put them in a different color here. I've got cosecant of theta, secant of theta, and cotangent of theta. And let's have a look at what they are. Just giving myself a little bit more room here. So the way to tell is looking at the 3rd letter. That tells you what it is the reciprocal of. So cosecant theta, sometimes written as cosec theta, or even CSC theta. And what is cosec theta? Well, it's the reciprocal of sine. So we'll remember from SOHCAHTOA, sine is opposite over hypotenuse. This is going to be the hypotenuse divided by the opposite side. Secant, that 3rd letter is C, so it's the reciprocal of the cosine ratio. So what was cosine ratio? So we write this as sec theta. Cosine, we'll remember, is adjacent over hypotenuse, so this is going to be the reciprocal of that. It's the hypotenuse divided by the adjacent. And lucky last, cotangent, you've already guessed, that's the reciprocal of the tangent ratio. So we write this as cot theta, and now we know tangent was opposite over adjacent, so this is adjacent divided by opposite. So there are 3 other ratios. Now, because our calculators, it's easy to find one and then just do 1 divided by what answer you get. We don't often see these on our calculators anymore, and they've sort of gone out of fashion. They were used a lot in navigation. Now when we're navigating, we use a GPS, so it's taken some of the use of these out. But they definitely do come up later on in grade 11 and 12 when we're doing some calculus and some derivatives, things you know nothing about yet, but will soon enough. So I think it's important for you just to be able to know that they exist and they're there. If you want a little challenge, write down write down all 6 ratios for this question here, or this triangle here, I should say. I'll put alpha in there. It's not always going to be theta either, is it? 5. What else is going to make that? Let's make that a 16 and a 9. That's still going to work for Pythagoras' theorem. I don't want to be a liar, so I better make sure I give you one that works. Did that actually work? No, it doesn't work. I meant to say 20 and 15. That's going to work. That's a bit better. Sorry about that. All right, so let's write down our 6 ratios. I'm going to pause, or you're going to pause the video and see if you can do it. Then come back and see if you get all 6 trig ratios right for this triangle right here. Best of luck. See you in a second. All right, so you've had a go. Let's see how you went. Well, I'm going to start by labeling my triangle because that's going to help. Hypotenuse, opposite, adjacent. So what are my 6 ratios? I've got sine theta is opposite over hypotenuse. I'm reminding myself SOHCAHTOA. Well, I'm really reminding you. I know SOHCAHTOA pretty well, but I still think it in my head. So sine opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse. Tan opposite adjacent. We get all of that from SOHCAHTOA. And then the reciprocal ratios. So the third letter, cosecant, cosec theta, sec theta, the third letter C, it's going to be the reciprocal of cosine, and cotangent of theta, and the reciprocals. So this was hypotenuse over opposite. See how it's reciprocal. Reciprocal of adjacent over hypotenuse is hypotenuse over adjacent. Reciprocal of opposite over adjacent, adjacent over opposite, and we can now write the answers. There's going to be 15 over 25. I guess I should have just made it a 3, 4, 5 triangle so you didn't need to simplify. So that's going to simplify down to 3 over 5. Adjacent over hypotenuse, 20 over 25, which is going to simplify down to 4 over 5. Tangent of theta, opposite over adjacent, 15 over 20, which of course will simplify to 3 over 4. The reciprocal ratios. Hypotenuse divided by the opposite, 25 over 15. That's going to be 5 over 3. Hypotenuse divided by adjacent, 25 over 20, 5 over 4. And adjacent divided by opposite, 20 over 15, or 4 over 3. Well done if you stuck around to get to the end of the video. Even if you skipped ahead, I promised a bonus word. I better throw the bonus word in. So today's bonus word, of course, is going to be SOHCAHTOA. All right, best of luck getting your work done. Well done for sticking around. Catch you in the next video. Bye.